All right, friends, so this is our last geometry lesson of the year. So sad. It's so sad. But we're going to go into the law of sines and the law of cosines. These two things are great little helpers to puzzles. I don't know about you guys, but during quarantine, my family has been kind of mini obsessed with puzzles. So we've been doing quite a bit of puzzles. Now, puzzles are fun when you have all the pieces, but sometimes things happen and people like Mr. Carl will eat a piece of your puzzle, and Miss Kiki will eat a piece of your puzzle. And then your puzzle isn't fitting together quite right. And you have to figure out, all right, these pieces fit here and this piece fits here. Well, how can I find this piece? That's where the law of cosines and the law of sines comes into triangles, triangle measurements, and vectors. So we're going to see how that all relates today, how we put them all together within trigonometry to make these beautiful pictures with all the pieces filled in. Okay, so here we go. Law of cosines and sines. It's puzzle day. So looking up at this whole bunch of words up here, I know when we look into our book, we kind of just skip over them, but these are actually this is really some good information. You can use the law of cosines to solve for missing measures of triangles when given two sides and the included angle, just like we did with the side angle side area theorem, or all three sides, side, side, side. So remember that highlighter? You're going to want to have it available with you today, okay? This identity is derived by using the Pythagorean theorem and basic trigonometric ratios. Here we go. Apply the Pythagorean theorem. So we all know a squared plus b squared equals c squared. Now in this one, you may be like, well, why do you have x and h and c? Well, that's because they're talking about the smaller triangle to begin with, okay? Apply the Pythagorean theorem to this triangle. Then a squared plus this whole side right here, b squared is c squared. So then they're talking about this pink triangle right there. Now they're going to go and they're going to expand this binomial right here. So this b minus x squared. So if you remember back from algebra, you would write b minus x times b minus x and expand it, which gets you b squared minus 2bx plus x squared, which gives you h squared. Now you're going to start doing some substitution. Since c is equal to x squared plus h squared, we are going to plug that in for our c side, okay? This right here. And when we expanded it right here to x squared plus h squared, we're going to substitute, instead of that, we're going to substitute in c squared. It's pointing to the wrong one. But note that x is equal to c times the cosine of a, right here. Okay, c times the cosine of a. So then instead of x next to the b, we can write c times the cosine of a plus c squared. Then all we have to do is some rewriting of it and rearranging using our commutative property. And we get a squared is equal to b squared plus c squared minus 2bc cosine of a. Now, some of you tuned me out and you're like, I am done listening to this woman. She is confusing me. But what I don't want you to tune out is this box right here that I'm bringing in. This is your law of cosines. You need to highlight this, star it, put it in your secret arsenal that you're going to use over and over and over. So all of these formulas right in here, all of these guys right in here, you are going to use and use and use and use and use. Now, typically we don't make you memorize these, and definitely with this style learning here, we're not going to make you memorize them, but put them on your list of special trig identities, okay? If you're making a special list, put them on there. I remember as a math major, I had like a little notebook I would keep around with area formulas and identity formulas, and it was all my little kind of quick reference things that would help me do my problems. So those are your nice little quick references. So please kind of keep those around. So I'm just going to move that up to here because we are going to use this and do a problem. So here we go. Here's our problem. Example 1. Example 1 says, find A in triangle ABC if the measure of angle A, I'm going to use this triangle that's up here to make my life just a little bit easy. So if the measure of angle A is 57, so this is 57, and B is 6, and C is 9. All right, so I'm looking for A. So since I'm looking for A, I'm going to use this guy right here. And I always, if you guys haven't learned by now, I always like to write my formula out first. So I've got A squared is equal to B squared plus C squared minus 2BC times the cosine of A. So I'm going to substitute in what I know. A squared is equal to B squared is 6 squared plus C squared is 9 squared minus 2 times B, which is 6, times C, which is 9, times the cosine of A, and angle A is 57. Okay, now here's where your calculator becomes your best friend. Hopefully you can put this in. Be very careful. Remember, your calculator doesn't understand what you mean all the time, so make sure you are very accurate in how you type it in. So I've got 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of 57. Now, if you typed it in properly, you should have gotten A squared is equal to 58.2 if you round. Now that's A squared, so now I need to take the square root. So you're going to hit square root, and I like to hit the little answer button, which puts 58.2 in there. So A is equal to about 7.6, approximately. Okay, so this is our approximate value for A. So I could go ahead and go write it in there if I wanted to, 7.6. Now, be mindful that you're going to have some rounding errors, especially if you are one of the people who wants to keep all the numbers exact and you don't round early on in your problem and you keep the exactness all the way through. You're going to hit some little bit, you'll be off just a little bit. It's okay. Don't worry about it. Don't worry about it at all. All right? Okay. Okay, so when we talk about the law of cosines, we have to look at all three sides. And sometimes we can start rearranging things to give us an easier access to different angles. Now, you could use each of the independent laws of cosines and work that way, or you can kind of rearrange it. Here's where your highlighter is going to come in handy, so I really want you to highlight these. This cosine of A, right there, highlight that guy, we'll be using it. This cosine of B, and this cosine of C. Now, if you want to see how we can derive that from the original, A squared equals B squared plus C squared minus 2BC cosine of A, you can join me during Zoom and ask me to work through that. It does work at step by step through here. Okay, it does work at step by step. But if you need help on that and you really want to know how to do that, join me and I'll help you. So now this problem in example number 2 asks us to solve triangle ABC. When I first saw it, I was like, solve what? But what they really want us to do is they want us to find the measure of angle A. They want us to find the measure of angle B. And they want us to find side C. So when we go ahead and do that, when we are working through our problem, when we go ahead and do that, we will have all this information, A, B, and C, and it will be generated, and I can just fill it in right there. So let's look at it. Okay, so the first thing I'm looking at is I don't know C. So I'm going to use my law of cosine. Let's go back there. Okay, sorry, friends. Let's go back to our law of sines, or I'm sorry, our law of cosines, and work through this problem. So now I don't know C. I'm trying to find C. So I'm going to look back at the law of cosines and I'm going to write down, well, C squared. No, I'm not. I will if I have a pen. C squared is equal to A squared plus B squared minus 2AB cosine of C. Now this just came from that little green law of cosines theorem box on the previous slide. So I'm going to fill in what I know. I don't know C squared, so I'm only C squared. A squared is 5 squared plus B squared is 6 squared minus 2 times 5 times 6 times the cosine of 78. Put that all into your calculator just like that. Just like that. Just stick it in your calculator just like that. And you will get the cosine of A is, the C squared is equal to just a whole bunch of mess and then say the square root. So then you have C is equal to 6.97. I'll give you a second to kind of work through it in your calculator. It's easiest if you type it all in and then hit square root answer. And what that'll do is it'll put the square root down there and then it'll take the answer that you previously had and plug it in under the square root. So C becomes 6.97. Now your book rounds it to 7. That's fine if you'd like to round it to 7. It's perfectly fine. It's very, very close. It makes it easy. If you want to be a little bit more precise, you can leave it 6.97. So I can fill in over here, C is equal to 7. Now if I want to find angle B, this is where these highlighted things come into play. Look at that guy. The cosine of B is A squared plus C squared minus B squared over 2AC. So I'm going to do that. I'm going to use that information right there. So here we go. Cosine of B is equal to A squared is 5 squared. I'm going to erase some of this stuff because I'm about to write on it. I run out of room on my screens. A squared plus C squared, which we found was 7 squared, minus B squared, which is 6 squared, over 2 times A times C. Again, stick this into your calculator. Please, please, please remember when you write it in the calculator. I'm going to show you how you would write it, calculator speaking. 5 squared plus 7 squared minus 6 squared divided by, and this whole thing needs to be in parentheses, 2 times 5 times 7, close parentheses. If you don't do that, it's just going to divide the first part of that expression by 2 and then multiply it by 5 and 7, and that will be wrong. So what you then will get is you'll get the cosine of B is equal to 0.543 approximately, and do the inverse cosine. So B is about 57.4 is what I was getting, 57.4 degrees. Now, you know that. So you know B is 57.4 degrees. Now, if you really want, you can use the cosine of A and find A, or you can say, look, I know two angles of this triangle. I can find the third angle because 180 minus 78 minus 57.4 is equal to boop, 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 44.6 degrees. So that would be the measure of angle A. So this is 44.6 and B was 57.4. Okay? All right, so that's using the law of cosines to find those angle measurements. All right, fantastic. So that's the law of cosines. Great, but we have another one to look at. We've got something called the law of sines. Now, the law of sines is very similar to the law of cosines. And no, I take that back. It is not similar to the law of cosines, but it is similar in the fact that it's going to give us missing pieces of information, those missing puzzle pieces, when we have a couple of the other puzzle pieces. Okay, here are your ratios. Remember when you got to learn ratios in grammar school, in middle school, and you're like, when am I ever going to use these? Here, you're using them here. You're still using them in trigonometry. So for any triangle A, B, and C, the sine of angle A over the length of angle A, or side A, is equal to the sine of angle B over the length of side B, equal to the sine of angle C over the length of side C. Or you can do the reciprocal of each of those. Flip it all upside down. Okay? All right, so looking here, this is how we kind of derived that information right there. The law of sines can be applied to solve triangles when two angles and any side are known, okay, such as angle, angle, side, or angle, side, angle. These are the cases where you will use law of sines when you have angle, angle, side, or angle, side, angle. This law can be derived by dividing each expression in the side angle side area theorem by 1/2 ABC. Okay, again, if you'd like me to walk you through that, I would be glad to walk you through that during class tomorrow. But if it's something you're like, I don't know, I'm just going to take it for fact right now, that's fine. I understand that too. You will be using that a lot more when you get into pre-cal and trig. Okay, so we're going to use the law of sines to help us complete example number 3. Now, the year just wouldn't be complete if you didn't see another Peacock masterpiece one more time. So here we go. I'm going to draw this picture while I talk you through it. A ranger in a fire tower spots a forest fire. Oh no, oh no. Here is the ranger's tower. Okay, and here's the ranger. He's got a hat on because he's a good ranger. He spots a forest fire. Oh no, oh no. Here's the forest fire starting to blaze. He spots a forest fire located 53 degrees south of east. So if we look at the forest ranger's line of sight and we look 53 degrees south of east. So his angle of depression of which he's spotting this forest fire is 53 degrees. Okay, everybody see that? Another ranger in a second fire tower, all right, he's over here somewhere. Oh, that was a pretty big fire tower. All right, he's over here somewhere. Same type of fire tower here. And here's our second forest ranger. He's at the same height. Doesn't look like it. Let me make it the same height. We'll make him the same height. There you go. All right, he's at the same height as this guy. And he's on his tower and he's looking out. He's got a nice little hat too. He's looking out. Now this tower is 12 miles east. So this whole section right here is 12 miles. He is 12 miles east of the first tower. When he looks out, he spots that same fire. He's looking out as well. He spots that same fire 45 degrees south of west. So he is looking west, but he is spotting it 45 degrees south of west. Find the distance from each tower to the fire to the nearest tenth of a mile. So these two guys with their binoculars up to their eyes, we know are 12 miles apart. Now we know this angle is 45, and we know this angle is 53. Now since I know two angles within my triangle, if you look at that white triangle, I can say 180 minus 53 minus 45. Well, let's do that. 180 minus 53 minus 45 is 82. So this angle right down here is 82 degrees. Okay? So that's kind of the angle at which their sight lines meet at the fire. Now I need to find, if I want to label this triangle, I'm going to label this triangle A. We're going to call this Ranger A. We're going to call this guy Ranger C. And we're going to call the fire B. Well, we know little b is 12. We don't know what side A is, and we don't know what side C is. That's what we want to find, because it says find the distance from each tower to the fire to the nearest tenth of a mile. Now, I know some of us might say, well, it's along the ground, but they want you to find this kind of diagonal length right here, okay? All right, so we're going to find this. We're going to use our law of sines. So I'm going to have to make this just a little bit smaller. There we go. So I'm going to use my law of sines. Now remember the law of sines. If we write it down, I'm going to write it up here. We have the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. So let's fill in what we know. What do we know in this formula? Well, we know angle A is 53 degrees. So we got the sine of 53. Do we know the length of A? Nope, I'm going to leave it. Is equal to the sine of B. The sine of B. B is 82 degrees. So I'm going to plug that in there. And the length on side B is 12. Is equal to the sine of C. C is 45. And the side C, we don't know. So now I want us to reduce these ratios, okay? Because this is where we're going to be able to solve. So the sine of 82, if we put it on our calculator, is like 0.99 over 12. The sine of 53, if we wanted to kind of, we're going to leave it like this, and I'll show you why. Sine of 53 over A, and the sine of 45 over C. So does everybody see we have two ratios, two sets of ratios? So I'm going to circle the first set. I want you to see that this is one set. So I'm looking for A. So I'm going to cross multiply and solve. I'm going to type in my calculator the sine of 53 times 12. The sine of 53 times 12 is 9. Whoa, I want to use a better pen. 9.58 is equal to 0.99 times A. Divide by 0.99 on both sides, and you get 9.7 is equal to A. So length A is 9.7. So this guy is 9.7 feet away from, or I'm sorry, miles away from the forest fire. So then we're going to do the same thing, except we're going to use these two as a proportion, and I'm going to cross multiply and solve once again. So I'm going to say the sine of 45 times 12. Well, that's going to give me about, let's use this, about 8.49. 8.49 is equal to 0.99 C. Okay, then I'm going to divide by 0.99 on both sides. divide by 0.99, and I get 8.6 is equal to C. So there we go. So this guy is 8.6 miles from the fire, while Ranger C is 9.7 miles from the fire. Okay? Questions on that one? Hopefully that one is pretty good. It's just the initial setup. The initial setup is kind of a little hard in this one. So I'm going to get rid of all this. Hopefully you're good. Again, remember, you can always pause and say, all right, I need to review this. Here we go. So this one might give us just a little bit more consternation. Let's think about this. So I want us to read this first thing right here first. The sum of two vectors can be found by solving the triangle formed by the vectors and their resultant. Now this one is a lot harder in its setup. So I would not expect you to be able to do one of these on your own, but I would like to talk you through it because I think it is super important, especially if vectors and engineering is something you want to go into. This is something you really need to kind of be familiar with. This is great for orienteering if any of you guys are looking into military or Boy Scouts or anything like that. Perfect example of how you use it in real life. Oh, here we go. The youth group. They hike from their base camp for 3 miles headed southwest. So the way I want to start this is I want to start this with kind of a nice coordinate system, putting their base camp at the origin of this coordinate. So they are hiking 3 miles southwest, and they say that's 45 degrees south of west. Okay? And they went 3 miles. Then if this is kind of their new stop point, then from this point, they hike 60 degrees north of west for 4 miles. So they go 4 miles, 60 degrees north of west. So that little triangle right there is 60 degrees. Now, what I want you to see is, I'm going to kind of erase this and draw it a little bit better here. What I want you to see is that this angle coming in here, this vector coming in here, I'm going to leave the tip off of it. This is still 45 degrees. Because if we made that a right triangle, it would have to be, right? 45, 45, 90. And then I am also looking at this 60 degrees. This angle right here has to be 30 degrees because 60 plus 30 is 90, making that right triangle. All right, so far I have this information. Now the question is saying from their base camp, how far are they and what is their relation, where have they hiked in relation, like southwest, northwest, what? So what we're asking is, what is the magnitude of this vector here, C, and what is this angle right in here, theta? So what I'm going to do is I'm going to draw just this triangle a little bit bigger, and hopefully you'll be able to see. So this triangle right here, this angle, I'm going to call this A, B, and C. Now C is this 45 degree angle plus theta. Angle A is this entire angle right here, which is 30 plus 45, which is 75. So that side is 75. Now this side over here is A. We don't know the measure of that side. This side over here, which would be our C, would be 4, and this side over here, which would be our B, is 3. So I'm going to use the law of cosines to figure this out. So the law of cosine says the side we're looking for, which is A squared, is equal to B squared plus C squared minus 2BC times the cosine of A. So I'm going to fill that in. A squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 75. Okay, make that a little smaller so I can keep writing on there. All right, so using my calculator, I'm going to take this and I'm going to put it all in my calculator. And I am going to get, let's see, 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 75. And that gives me a squared is equal to 18.8 if I round. And the square root of that answer is 4.3. So a is equal to 4.3. So the magnitude of this vector, the magnitude a of this side, we labeled it c in the first example, which is where I got a little confused, but it's really a. So the magnitude of that vector a is 4.3 miles. Okay, that's this vector, this red vector that I drew in this picture right here. Okay, that's that red vector. So it's 4.3, not 43. There's a point there. All right, and now I need to find the angle. I need to find theta. Okay, I have 45 plus theta, but I need to find theta. So I'm going to use, remember when we highlighted a little bit of the way we can manipulate the law of cosines, and we said, all right, well, we can find the, I'm gonna make this a little bit smaller. We can find the cosine of c, or I'm sorry, yes, we can find the cosine of c by looking at the cosine formula, and it was on near example number 2. It's on your notes near example number 2, and we can say the cosine of c is equal to a squared plus b squared. Yeah, a squared plus c squared, b squared minus c squared over, I'm having to look in 3 different places, 2ab. So I'm going to fill that in. I don't know the cosine of c. I don't know the entire angle c. I know it's something plus 45. But I do know that a squared, which is what we found, was 4.3 squared, plus b squared, that would be our 4 squared, minus the, nope, the b was 3 squared. Reverse. This is 3 squared. Okay. Minus c squared, which is 4 squared. Over 2 times 4.3 times 3. All right. Popping all of that into our calculator. Again, remembering how to type it in. So we're going to say 4.3 squared plus 3 squared minus 4 squared divided by, put it in grouping symbols, put it in parentheses, 2 times 4.3 times 3, close parentheses, hit enter. Okay, once you hit enter, you are going to get something that I didn't get. I got something off. And I'm not sure why. Hold on. I'm thinking. Okay, so I just realized I had an input error on my calculator because it was not giving me what I wanted. And so if I have an input error, I'm sure you do as well. Remember when you put it in your calculator to put this entire quantity in parentheses and then divide by this entire quantity in the denominator. When I put it in my calculator just a second ago really fast, I forgot to do that. And what it did was it was dividing just 4 squared by 2 times 4.3 times 3, which was throwing my number off. I was like, I should have gotten like a decimal. I should have got a point something, but I was getting a large number like 26 and it wasn't working out. And I was like, what did I do? I just didn't put my grouping symbol up in the numerator. So now once I do it the proper way, I get the cosine of C is 0.45. And if I needed to do the inverse, now to solve for C, I need to do the inverse cosine of that answer. And that gets me C is equal to 63.5 or 63.6. Now that's that entire angle C. That's this entire angle here. Well, we're just looking for theta because the question says what is the location in relation to their base camp? So what we want to find is that theta, just the 45 goes up to the negative x-axis. We want to find the angle from the negative x-axis up to that vector. So that's theta. So we're going to subtract 45 from this, and then that would give us that theta is equal to, subtract 45, and 18.6 approximately. So my theta, or my direction, is 18.6 degrees. Now how we would say it, 18.6 degrees north of west, or you could say 18.6 degrees above the negative x-axis. But since we're talking directions and we're talking hiking, we're going to say 18.6 degrees north of west. Okay? All right. That's a hard one. I'm probably not going to go that far into it with you guys, especially given this situation we're in our fun distance learning. But hopefully you're kind of seeing all this information and you're loving it and it's making you happy, happy, happy. All right, so your homework for tonight is 1 through 19 odd. Get that attempted or attempt it with me during the Zoom class tomorrow. This, my friends, is your last lesson in geometry. Way to end it with a bang, right? This is probably the most biggest compilation of everything we've done all year. We've got angles, we've got thetas, we've got cosines, we've got vectors. This is side angle, we even threw a side in there. This is just kind of your wrap it up at the end of the year in a nice little pretty bow. Okay? You will have your quiz over 12.5 and 12.6 tomorrow, and then I am going to go ahead and put your Unit 12 test. I have it on the schedule for next Tuesday, reviewing on Monday. But if you're ready to take your Unit 12 test right now, my friends, you feel free to do so. All right. I don't want to say goodbye. I don't want to say goodbye. Parting is such sweet sorrow. But I will see you later when you turn your books in. All right. Have a good one. Talk to you later. Bye.